Hello. Yes, we can wait for 1 or 2 minutes. Then we can start. Hello. I guess it is audible. Hello. I guess it is audible. Hello. Yes. We will start soon. We can wait for 1 or 2 minutes. Then we can start. I guess we can start it now. We can wait for 1 more minute. Then we can start soon. Yes. Shall we start? We'll start with enthusiasm, curiosity in physics. And today is the very most important day, the first day of class 10th standard live stream. Welcome to Physics Cartoon Camera. Welcome to Physics Cartoon Camera. I guess my voice is audible. My voice is audible to the students. Yes, Physics Cartoon Camera. You can observe in this channel recording classes of class 6th standard to MSc, which is continuously recording, and science facts, laboratory experiments, hands-on experiments, jobs in physics, invited talks by physicists, practical applications in our surroundings, and live stream sessions from class 9th standard to up to post graduation. So every day, night 10 to 11 p.m. So the basic concern over here to reach to the rural India, we can able to study physics. Now today the topic is electricity of class 10th standard. So what is electricity? What are all the remaining parameters we are seeing now? Hello. Yes. Now generally nowadays electrical bill is more. Electricity is very more, like electrical bills, expenditures. So what is electricity? What is exactly the idea of electricity? So electricity, generally there is a term called as electron. The flow of electrons we called as electricity, what we studied in class 8th standard. Yes, Now coming to class 10 standard, electricity term changed. So what is electricity and what is electric current? The basic themes we can study now, the basic concepts of electricity. Then we can go ahead with class 10 standard, what is the syllabus criteria. So we know that flow of electrons called as electricity. Is it really a flow of electrons? We will see that. Yeah. We will see. Just a minute. Yeah. Yes. Yeah. We can start. Yes, one of a student want to join now. Yes, most welcome. Who need physics today? The most important, we need to invite the student. They are from rural India, and we will see how the best way can help to the student. We'll see that they want a link, it seems. Yes, we can. Yeah. Yes, we'll start now. This might be they're joining a group of children. We can wait for them. We can invite them who need physics. This is my dream to help the students in the rural country. Yeah, might be yes. Fine. We will start. Continue. Yes, they can able to join now. We'll see that. Or live stream itself we can able to send here. She can able to join. Yes. Sure. Now, the flow of electrons. Flow of electrons we have studied before. Okay. Flow of electrons in the sense of negatively charged particle. But in where these electrons, which is in atom, center part is nucleus, electrons are revolving around the nucleus. Now we removed all the electrons, only positive will be inside. As per the Rutherford Bohr theories, number of electrons is equal to number of protons. If you remove all the electrons, atom may not exist. We can't remove only the negatively charged particles. Okay. Now just we reframed. How many electrons are coming from negative terminal to positive terminal? Same protons also which is flowing from positive terminal to negative terminal. Okay. So the flow of charged particles. The flow of charged particles, we can call it as electricity. So charged particles in the sense of both positive and negative. Okay. This is called as a charged particle. Now electricity defined as the flow of charged particles is called as electricity. Clear? Now electricity, yes, it's a form of energy. Sound energy, light energy, heat energy, kinetic energy, potential energy, and so on, many kinds of energy. But what is the speciality of this electrical energy? Electricity is just another form of energy, a more controllable and hence convenient form. That's the reason there is a speciality in this topic. Okay. Now, sometimes we will come from the school to house. We may speak generally to mom. Mom, current is there? Normally we can speak to mom. What mom will do? She will see the fan or bulb or any indicators. She will say that yes, it is there or not. Same question we will ask to mom again. Mom, power is there? Again mom reaction is the same. Mom, how much electricity bill? If it is more comes, then we will see again the bulb and fan only. So electricity. All the three expressions, the three words are giving the same expression. So what is current exactly? Current means, exact meaning is flow. Okay. So how it is? Let's say air is flowing from high pressure to low pressure. That's called as air current. If water flows from height to low, that is water current. If charged particles flows from higher potential to lower potential, that is electric current. That's called as, that's what we will say, mom, current is there. Now, what is electric current? Electricity is over now. Electric current, how to define? Electric current we can define as the flow of charged particles in unit time. Okay. Definition of electric current again, the flow of charged particles in unit time. Charge symbol Q. Okay. Charge symbol Q. Time T, which is in seconds. Okay. Charge units coulombs. Time units seconds. Fine. Electric current I is equal to, again repeating, the flow of charged particles in unit time. Charge units coulombs, time units seconds. Now electric current units amperes. Fine. Now the CBSE will ask a question. Define 1 ampere. Define 1 ampere. 1 coulomb by 1 second. So we can define it. The flow of 1 coulomb of charged particle, 1 coulomb of charged particle flowing in 1 second of time. in 1 second of time is called as 1 ampere. Alright. So this is 1 ampere definition. Next we will proceed. So what is charge? How it is? Let's say one electron is equal to 1.6 into 10 to the power of minus 19 coulombs. One electron is equal to 1.6 into 10 to the power of minus 19 coulombs. In 1 coulomb, how many electrons will be there? In 1 coulomb, how many electrons will be there? Very simple. So 1 by 1.6 into 10 to the power of minus 19 electrons in 1 coulomb. So 1 by 1.6 into 10 to the power of minus 19 take top, which is 10 power 19. So 1 by 1.6 we can make it as 0.625 into 10 to the power of 19. Still we can write the best way 6.25 into 10 to the power of 19. Okay, no, 18. One digit will be less. 6.25 into 10 to the power of 18. Generally 6 into 10 to the power of 18 electrons. Now electric current we can measure with a meter. Okay, units are amperes. How does a metal conduct electricity? The motion of electrons in a conductor is very different from that of charges in empty space. When a steady current flows through a conductor, the electrons in it move with a certain average drift speed. Okay. Now let's see what we understood. There are some CBSE related questions. A current of 0.5 amperes is drawn by the filament of an electric bulb for 10 minutes. Find the amount of electric charge that flows through the circuit. How to answer this question? A current of 0.5 amperes is drawn by the filament of an electric bulb for 10 minutes. So students, whenever the physics numericals, don't confuse. Once read the question again. While reading the question, identify what is given data. Always I'm suggesting you, while writing the given data, we no need to read the question back again. We will save the time in examination time. So current I is equal to 0.5 amperes. By the filament of an electric bulb, time t is equal to 10 minutes. This is given data. So what is required data? Which means what they are asking from us. One is electric charge. Find the amount of electric charge Q value, how much? So option A 100 coulombs, option B 200 coulombs, option C 300 coulombs, option D 400 coulombs. So what is the answer, audience, the students? Any idea what is this answer? What is your expectation answer? Yes, you can chart option A, option B, option C or D. Don't worry if it is a wrong answer. Proceed what you got it from here. Anyone? So this is given data and this is required data. Now we are asking about Q. Shall I proceed? Yes. I is equal to Q by T. Okay. Now time they have given in minutes, convert into seconds into 60, which is 600 seconds. Now current I is equal to Q by T. Q is equal to I into T. I value how much? 0.5 amperes into time 600 seconds. It comes as 300 coulombs. So the option C is the right answer. Okay? Option C. Now, what is the SI unit of electric current? What is the SI unit of electric current? Volt, ohms, coulombs, ampere. Electric current, just we defined I is equal to Q by T, the flow of charged particles in unit time. Current we are measuring in amperes. Option D. Next, calculate the number of electrons constituting in 1 coulomb of charge. Just now we have discussed. In 1 coulomb of charge, how many electrons will be there? Option A, 4 into 10 power of 18 electrons. Option B, 6 into 10 power of 18 electrons. Option C, 3 into 10 power of 18 electrons. Option D, 2 into 10 power of 18 electrons. Audience can respond. Audience can respond. Very easy question. Calculate the number of electrons constituting in 1 coulomb of charge. This question generally CBSE board paper, it appears many times. So just now we have discussed 1 electron is equal to 1.6 into 10 power of minus 19 coulombs. In 1 coulomb how many electrons? We discussed 1 by 1.6 into 10 power of minus 19. After solving, how much we got? Yes, 6 into 10 power of 18 electrons. Option B. Next, which device used to measure electric current? If anyone knows the students, you can able to respond it. Option A, rheostat. Option B, voltmeter. Option C, ammeter. Option D, none of these. Electric current units are amperes. Okay, so you can able to guess it. Amperes, which word is nearby to you? Rheostat, voltmeter, ammeter, none of these. So you can choose the right answer. That is ammeter, right answer. Amperes are the units. Now see in this picture, one is open circuit, other one is closed circuit. In open circuit, we noticed bulb is in off condition. In closed circuit, bulb is on condition. So what it is? How to define open circuit and closed circuit? Battery, this battery, just I changed the name as source. Can we call it as a source? Yes. Bulb, I named as indicator. Indicator. Wires, we can call it as connectors. As a technical word, connectors. So how to define open circuit? The open end of source, indicator and connectors is called as open circuit. Now can we define as a closed circuit? Closed end of source, indicator and connectors, we can call it as closed circuit. Fine. Here just the word is open end of. Open end of source, indicator and connectors called as open circuit because electricity won't flow from this end. Closed end of source, indicator and connectors, we can call it as closed circuit. Clear? Now we will see the next topics. Electric potential. Electric potential difference. Many students send email to me, sir, what is the difference between electric potential and potential difference? This is the confusion. Most of the children. So what is potential? Normally in the classroom, if we ask a question to any student, what is your potential? The student might say what is his caliber, what he can able to do the best. Some children will say that, sir, I can read 2 hours continuously without any disturbance. That is my potential. Other children will say, I can eat more food, sir. That is his potential. Which means, potential, the meaning is what we can do the best. Yes. But what is electric potential? We will discuss now. Let's say there is a charged particle. You know that there is any charged particle which is having its own field. Yes or no? So how to express this own field? Let's say you put a light, take a candle, put a light on that. Put a finger far away. We won't feel any warm. The same finger put it very closer to this candle. We can observe there is something heat. So you can see what is the range of the heat. Okay, what is the range of the heat? So that is called as a field over there. Similar way, any charged particle which is having a certain field over here. One more charged particle from infinitive, which means out of the field. Out of the field from any place. Charged particle we are bringing from infinitive distance to this electric field region. For this we are doing work. We are doing work on charged particle. So how much we are doing work on charged particle, that is electric potential V. Okay. V is equal to W by Q. Work done by the charged particle is called as electric potential. Now what is potential difference? You can compare the two electric field regions. Let's say somewhere. This is at point A and this is at point B. Okay. Now any another charged particle bring from infinitive distance to at point A charge. That potential is VA. Let's say the same charged particle from bringing from infinitive distance to another field of B. Let's say that potential is VB. The difference between these potentials VB minus VA, we can call it as potential difference, which means the difference between two potentials. The difference between two potentials we can call it as potential difference. Hope you understood now what is electric potential and potential difference. Is it clear? Now, how to define now in wordings? Work done by the charged particle. Okay, electric potential we can define as work done by the charged particle. By the charged particle. So W by Q, work done by the charged particle, is called as electric potential. As simple we can able to define. Potential difference, the difference between two potentials. The difference between two potentials, which is VB minus VA. Clear? Yeah, hope you got it. Next. Yeah. It's an analytical pressure on water or air. Is there some kind of electric pressure on electrons that move them? But what is electric pressure exactly? Who exerts it? We will see in details. Yes, just we studied about V is equal to W by Q. Work done by the charged particle is called as electric potential. Units are volt. Electric potential units, volt. Work done units, joules. Charge units, coulomb. Okay. Define 1 volt. 1 joule by 1 coulomb, which means 1 joule of work done by 1 coulomb of charged particle is called as 1 volt. Clear? Again I am writing here 1 joule of work done, 1 joule of work done by 1 coulomb of charged particle is called as 1 volt. Clear? Next, we'll proceed. Yes, let me see what you have understood. How much work is done in moving a charge of 2 coulombs across 2 points which is having a potential difference of 12 volt? Option A, 6 joules. Option B, 3 joules. Option C, 24 joules. Option D, 12 joules. Repeating. How much work is done in moving a charge of 2 coulombs across 2 points having a potential difference of 12 volts? Audience, anyone can answer this. Just in question paper, if you read this question, charge q is equal to two coulombs. Potential difference V is equal to 12 volts. So they're asking about work done. As per the definition of electric potential V is equal to work done by charge particle. Now work done is equal to electric potential into charge. So 12 into 2, which is 24 joules. So option C is the right choice. Clear? So this is the way we can able to answer the questions. Name the device which helps to maintain a potential difference across a conductor. Option A, resistor. Option B, battery. Option C, ammeter. Option D, voltmeter. So here you can see electric potential, voltmeter. Suddenly we will choose it. But read the question properly. Name a device that helps to maintain the potential difference. Voltmeter is the measurement to electric potential difference. But which device can help to maintain the potential difference? This is one of a logic question. So don't confuse. So potential difference, volt, this number where we are noticing? Generally on the battery. Battery having that so and so potentials. Okay. Now maintain the potential difference is battery. Clear? So this is the way we need to answer. Which device used to measure potential difference? Option A, rheostat. Option B, voltmeter. Option C, ammeter. Option D, none of these. Hope you can choose the right answer, that is voltmeter. Yes. Which quantity is represented by joule per coulomb? See the question here. Which quantity is represented by joule per coulomb? Option A, potential. Option B, work done. Option C, current. Option D, charge. So what it is? This kind of questions we need to think very decently. V is equal to W by Q. This is the formula. Work done units joules, charge units coulombs. So what quantity it represents? V refers to electric potential. So that is the right answer. Joule per coulomb is electric potential. How much energy is given to each coulomb of charge passing through a 6-volt battery? Repeating again. How much energy is given to each coulomb of charge passing through 6-volt battery? We will see that what is given data. How much energy needed? Charge each coulomb. Q is equal to 1 coulomb. V is equal to 6 volt. How much energy? Which means in the form of work done. V is equal to W by Q, which means W is equal to V into Q. V value 6 volts, charge 1 coulomb, which is 6 joules of energy. Hope you can agree with me. So the right option is option A. Now always we can't draw the battery and many electrical appliances. For that we are using symbols. The symbols we can see that what it is. Most important in 10th standard CBSE board, they will ask you at least one symbol. We can clearly learn it what kind of symbols it is. Let's say electric cell. The word cell which refers one long lead and short lead. Long lead indicates positive, short lead indicate negative. Next, battery. So there is the two different cell, battery. In our common word, cell, battery both are same for us. But while coming to symbols in class 10 standard, battery is a combination of cells. So combination of cells, some of the years they give an MCQ question. So the MCQ question they'll give, and these combination how we have to draw is the most important. Always if you start with negative terminal, positive terminal, then positive terminal has to connect it with the negative terminal, positive terminal, again negative terminal, positive terminal, stop here. If you start with the negative terminal, another end has to stop with positive terminal. Always remember. In MCQ questions they'll be confused. Yes. Or else if you start with positive terminal, negative terminal will connect it to positive terminal. Again there is a space. Negative terminal connected to positive terminal. Again negative terminal. So this is the way. If you start with the positive terminal, end with negative terminal. Okay. So this is the way we need to choose the answer, a battery or a combination of cells. Long lead, short lead, long lead, short lead, long lead, short lead. Clear? Plug key or a switch. There is an open switch. Plug key or close switch. If you put a dot over here, this is close switch. Wire joint. Two wires, for example, why the wire joint is required? Let's say yes, one of a student is asking, what is potential? Can you explain again? Yes, sure. You see, there is a charged particle over here. Let's say one charge. Every charged particle having its own electric field. Yes or no? Yes. Now we are bringing one more charged particle from infinitive distance to this field region. You are bringing one more charged particle to this region. For that, we are doing work. We are doing work on charged particle because we are bringing charged particle. Yes, that is electric potential. Fine. Electric potential we can define as a charged particle bringing from infinitive distance to electric field region is called as electric potential. Work done by the charged particle, as simple as such. But potential difference in the sense of the same charged particle we taken to another area. Let's say another charged particle is there, that is another area. Let's say point A over here, point B over here. This potential will be VA and this potential will be VB. That difference between two potentials we can call it as potential difference. Hope the gamers king, hope you understood that. What is potential and potential difference? Yeah, now we can go ahead with our symbols. Wire joint we are explaining. What is wire joint? Why that dot point is required? Let us consider this is one wire and this is another wire. Okay, I'm placing you before to you. Both the wires, you can see that. For you, it look like joint, but in fact there is a space over here. While far away these wires are looks like jointing, but exactly it's not jointing. There is some space. If any joint wire in a diagram, what we can do? Yes, exactly jointed, which means for that we are placing a dot point. Wire crosses without joint. If you put this line, means overlapping, which means both are not jointed. Electric bulb over here and resistance. Resistance we will discuss now. What is resistance? And variable resistance. What is the difference between a resistance and variable resistance? For example, I'll show you in a diagram what is resistance and variable resistance. Variable resistance in the sense of at a certain time we can able to increase and decrease the resistances. We can increase the resistance and we can decrease the resistance on spot. That is variable resistance. For example, I need 10 ohms. Immediately I need 20 ohms. You can able to increase it. We can vary it. But fixed resistor, we can't change anything. That is resistor. Next, ammeter. Ammeter, electric current we are measuring with ammeter. Electric potential, voltmeter, this is V. So these are all the symbols. Most important symbols what I noticed, battery connection. This is battery symbol most of the time. Wire joint they have asked. And variable resistor and rheostat this area. Generally resistor they asked. Yeah, most of the time. Sometimes open key or closed switch kind of. And one more symbol is there, that is tapping key. Here it is not there, but what I noticed in some of the question papers, tapping key, which means if you switch on, electricity will be pass. If you leave it, electricity will be off. When it is, let's say calling bells or horns, automobile horns. If you press it, current is flowing. If you leave it, current is stopping. Yes, that is called as a tapping key. Hope you understood. So this is one kind of symbol what they are asking frequently. Next, see, this is the cell, battery, plug key, switch, resistor and rheostat. Ammeter, voltmeter, multimeter. So multimeter in the sense of, you can see an electrician while doing any kind of repair shops, you can see that this kind of machine. Here you can measure ohm, like resistance you can able to measure, electric potential you can able to measure, current we can able to measure, diodes, whatever other things also we can able to measure through here. In AC and DC both we can. So all the things in 1 meter, that's called as a multimeter, as simple as such. So ammeter and voltmeter, these are all the themes. Next, before going to Ohm's law, what is resistance? What is resistance? This is very common word. Yes. How it is common word? We'll say. Sometimes in a ground, children will be run. PT teacher will say that yes, run. Some children will run very fast. Some children's little bit they'll run, then they'll stop. Then they'll discuss, hey, the student don't have that much resistance power. So kind of common words we are using. What is resistance? Simple example I'll tell you. You are on a running ground and you started running. Yes, very fast you are running. Then end of the ground, there is a big swimming pool. Can you run with the same speed? Exactly no. Because water molecules will be stop us. We can't run with the same speed as the air medium. Yes or no? So which is opposing our run? That is resistance. At the same way, I can explain you through experimentally what is resistance exactly. Take a battery. Long lead indicates positive, short lead indicates negative. We can connect it through bulb. Yes, we can connect it through bulb. Wait for 10 minutes or 15 minutes or 20 minutes. Then disconnect it. Touch the bulb. We will get heat. Why the heat is coming? Or touch the wire. We'll feel some warm. Yes. Why it is? I'll tell you exactly. So from the positive terminal to negative terminal, at the same time negative terminal to positive terminal, flow of charged particles is called as electricity, what we discussed. While flowing these charged particles, this wire also made up of a metal which contains again atoms, electrons, protons, neutrons, everything is there. Now these existed electrons are opposing the flow of electrons, which means the opposition of flow of charged particles or the opposition of flow of electrons, whatever you can say, that is resistance. Due to the resistance, bulb becomes warm. Yes, resistance we can define as the opposition of flow of charged particles. The flow of charged particles is called as resistance. Resistance symbol, yes, this is resistance symbol. Units ohm, OHM. Ohm symbol, this is. Clear? One of a student is asking a doubt. Just a minute. The doubt here, I'll explain him. Just a minute. Yeah. The name of machine in which voltmeter and ammeter measured by having parallel series. Generally, if you want to connect it to any machine, depends on our requirement. If you want to identify how much electric current, we are connecting ammeter. And if you want to potential difference, we are connecting voltmeter. But your question, name of machine in which voltmeter and ammeter measure by having a parallel series, it is like not a right way to the question here. I'll explain what is your meaning. So what I mean to say this, Voltmeter and ammeter, how we are connecting in electrical circuit? I think so. This is the question. That answer will come to know now. Is it the same question what I'm expecting? What you want to say to me? How to connect ammeter and voltmeter either in parallel series in a circuit? So that is one question what I analyzing from your doubt. Yes, I'll do it now. Yeah, this is resistance. Units are ohms. Now, what is Ohm's law? Just give a 1 or 2 minutes time. I'll conclude your answer what it is. Ohm's law can say that the relation between electric current, electric potential and electric resistance is called as Ohm's law. The relation between electric current, electric potential and electric resistance is called as Ohm's law. So we will see what Ohm's law did. Let's say he taken a battery. Battery he connected to closed switch. What happens? Current will be flow. Current will be flow. How much current is flowing? He connected ammeter in series, because the series and parallel children might be not know that after Ohm's law the series and parallel will come. But as you asked me the doubt, yes, my responsibility to answer your doubt. So ammeter we connected in series. Then why we connected ammeter over here? How much electric current is flowing from the battery? That's our concept. Then ammeter to again variable resistor we connected. We discussed what is variable resistor. We can able to increase and decrease the resistance. That's called as variable resistance. Across variable resistance, voltmeter we connected parallelly. Okay. Then you connect one more fixed resistor for the safety of this device. This is called as a Ohm's law circuit. Again I'm repeating. Battery connected to closed switch to ammeter, ammeter to variable resistor parallelly voltmeter, again fixed resistor we connected over here. Circuit is closed. Now what Ohm did? Ohm taken a certain condition. Ohm's law is applicable at room temperature only. At room temperature he made this experiment. Let's say I gave you a torchlight with one battery. Switch on the battery. What you will notice? Little light will come. Two batteries, torchlight I gave you. Still more light you might be notice. 3 batteries, still more light. 7 batteries, still more light. So how many batteries we are increasing, that much light intensity, which means electric current is flowing more. Yes or no? So now once batteries increases, electric current also increasing. Okay. Once batteries increases, electric current also increasing. That's what we are notifying through ammeter. At room temperature, proportionality constant we are taking as a resistance. This is the shortest way. V is equal to IR, Ohm's law. But I want to explain in another way. So V is directly proportional to I. Yes, this is the first equation. Here we connected variable resistance. Let's say variable resistance is 0, which is allowing all the charged particles from the battery. So let's say from battery negative terminal, 1000 electrons which is flowing, the 1000 electrons are reached over here. This is the 0 ohms we given, all the 1000 electrons will reach over here. Yes or no? Now the difference between these potential will be again 0. Yes. Now let's say 10 ohms you increased. What happens? Here up to 1000 electrons will come. Here it will comes to only 990 only. Yes or no? Because 10 ohms resistance. Resistance itself opposition of flow of charged particles. Now the difference is 10 volt over here between the 2 points. Again still you increased 20 ohms. All 1000 electrons in that 980 only will be reached. Again the difference is again 20. One way you are increasing resistance, electric potential also increasing. Yes, this way you can understand that V is directly proportional to R. Yes or no? So from 1 and 2, V is directly proportional to IR. V is equal to IR at room temperature. So finally whatever the relation between IVR is called as Ohm's law. While taking the graph over here, Ohm's law graph will indicates once electric current increases, electric potential is increasing. In fact, if current increases, potential will be increased. I is directly proportional to V is the right answer. Exactly. But we will study that in higher standards. Right now, potential increases, current is increasing. Clear? Any doubt in the Ohm's law? Now the student asked a question. Ammeter we are connecting in series, voltmeter we are connecting in parallel. Why the reason? Might be that is the question. Ammeter connecting in series because ammeter resistance is less value. Ammeter having its own resistance, voltmeter having its own resistance. So the less resistance we connected over here, more resistance we connected there as a parallel. If you connect in voltmeter, due to the more resistance of the voltmeter, if you connect in parallel, exactly potential difference we can able to identify. Ammeter internal resistance is less, connect in series. That's what we connected in series. Hope you understood the doubt the student gave us king. Is it clear why we connected series and parallel? That we are discussing in next subchapters. What is series and parallel? Hope your doubt is clear with me. Shall I proceed? Yeah, I'll proceed it. Now the same thing I have explained over here through graphically V and I. Yes. Now there is question for you. How much current will an electric bulb draw from 220 volts of source if the resistance of the bulb filament is 1200 ohms? Sir, numericals is facing a problem in examination. I don't know how to solve the numericals. Children generally they'll worry about that. Always I'll suggest you while reading the question, mention given data and required data. What is given data? What is the meaning of this? Given data in the sense of what they given in the question. As simple. So electric bulb potential of 220 volts, V is equal to 220 volts they given. And the resistance they have given 1200 ohms. What they are asking? Electric current they are asking. After writing given data and required data, we no need to read the question again. We will save some time. Now, electric current we want it. So which formula? The relation between IVR just now we have discussed. V is equal to I into R. Yes. From that I is equal to V by R. But it is the student is asking that please give 2 in every question. Yeah, fine, sure. I is equal to V by R. V value how much? 220 volts by R 1200 ohms. If you solve it, 22 by 120, approximately 0.18 amperes. We need to solve that. Yes, exactly. C is the right option. So according to the given data and required data, what formula, just substitute it. This kind of decimals, please be alert. Decimals value should not be other things what we are doing, because 18 amperes, 0.18 amperes, 1.8 amperes, 0.01 amperes, these are all very nearby numbers. So we should very carefully solve that. Next question. How much current will an electric heater coil drawn from 220 volts of source if the resistance of the heater coil is 100 ohm? Again, always recommending to write the given data. V is equal to 220 volts and the heater coil R is equal to 100 ohms. I is equal to V by R. So 220 by 100. So that is exactly 2.2 amperes. Yes, within seconds we have solved now. Numericals are very easy in physics now. 2.2 amperes. Next question. The potential difference between the terminals of the electric heater is 60 volts when it draws from the current of 4 amperes from the source. What current will the heater draw from the potential difference is 120 volts. So see this question very logically we need to think. We no need to solve the numericals as much. Sometimes physics questions will make us confused. We need to think very gently to solve the answer. We no need to solve the answer if it is an MCQ. Directly we can able to attempt. I'll give a clue. The potential difference between the terminals of a heater, 60 watts. If you connect 60 volts, 60 volts given that 4 amperes. If it is 120 volts, how many amperes? That is the question. Yes, this is a logical thinking. V is directly proportional to I as we studied. 60 volt it is giving 4 amperes, 120 volts which means double of that. How many amperes? Yeah, don't worry. Yes, you can solve it. I'm saying as a clue. Yeah, yeah. That is 8 amperes. Hope I'm suggesting you how to think to solve the answers. Alright. So probably up to Ohm's law we have completed. This class we discussed about electric current, electric potential and electric resistance. As a short notice, I'll tell you one thing. Electric current, the flow of charged particles in unit time is called as electric current. Electric potential, work done by the charged particle is called as electric potential. Resistance, the opposition of flow of charged particles is called as resistance. Okay. Now, electric current units are amperes. 1 ampere we defined as 1 ampere we defined as the flow of 1 coulomb of charged particle in 1 second of time is called as 1 ampere. We measured with ammeter. Electric potential V is equal to W by Q. 1 joule of work done by 1 coulomb of charged particle is called as 1 volt. So voltmeter we measure with. Then the relation between IVR we can call it as Ohm's law. Yes. As per the Ohm's law, we connected battery to closed switch, and again we connected to ammeter to variable resistor, across variable resistor voltmeter, again we closed it. So once electric potential increases, electric current is increased, so V is directly proportional to I, so V is equal to IR at a room temperature. Hope it's clear, and the numericals also perfect. So thank you so much the students to listen my class. And in my busy schedule, I'm categorizing 1 hour to the students of a rural country, and all the CBSE pattern I'm teaching to you. Listen carefully, and if you have any doubts, yes, you can chat with me, and in my description there is an email ID. You can post me any questions, I can answer you. Yes, don't worry. Every day 10 to 11 p.m. This 2 to 3 weeks I'm teaching class 10th CBSE, and other than the curriculum I'm teaching accession and reasoning, case study based questions, how we can able to get the best marks in physics. So thank you so much for watching my channel, and you can see the description what I'm providing to you. There are the science facts and hands-on experiments, science activities, one by one I'm trying to implement to reach the students. Thank you so much. Have a nice day. Good night. Jai Hind.